Introducing COMSOL 4.4, the newest version of COMSOL Multiphysics, sporting a brand new look and feel. With this latest release, we have a more streamlined COMSOL desktop, improving usability and augmenting your simulation workflow. The 4.4 release also brings you a new feature to assist your multiphysics modeling and help better organize it. These enhancements set the stage for many other improvements and additions that have been made throughout the COMSOL product family. The COMSOL user interface has been enriched with a ribbon design to provide you with a better modeling experience. This COMSOL ribbon streamlines and enhances your modeling while still allowing an overview of your simulation workflow in the model builder. Instead of working top to bottom and right-clicking to select your options, you may now also work from left to right in the ribbon and access functionality directly. Within the ribbon, all the steps to building a complete model are available. Creating your model, adding definitions such as parameters, variables and functions, building or importing your geometry, defining the various multiphysics characteristics, meshing your model, modifying its study steps and solver settings, and post-processing your results. COMSOL also introduces new functionality to facilitate your multiphysics simulations. The multiphysics node allows each of your defined physics to be approached, either separately or coupled, so that you can have better control over the modeling process. Years of experience developing multiphysics software has led us to this method for governing these modeling approaches. The new functionality provides a comprehensive and transparent overview of your multiphysics models and the physics that are involved in their simulations. A streamlined workflow to easily extend single physics simulations to create a multiphysics model, where couplings are automatically applied, and the ability to directly enable and disable specific physics to allow various simulations on the same model throughout your modeling workflow. Many other improvements have been made to the core functionality of COMSOL Multiphysics. This includes the ability to export 2D and 3D meshes in the Nastran file format. It's easier to create complex geometries by defining and utilizing user-defined primitive objects. And you can specify time units for the solvers, model your systems from microseconds to years. The Mixer module is an add-on to the CFD module and is new with COMSOL 4.4. It is the perfect tool for understanding, designing and controlling mixer operations in a variety of applications and is used within the food, consumer product, pharmaceutical and chemical industries. Able to model both laminar and turbulent flows affected by rotating machinery, this module utilizes sliding and moving mesh technology to model fully time-dependent, pseudo-steady state and free surface mixing applications. Further improvements have also been made to the fluid flow capabilities within COMSOL. This includes a feature to define wall roughness for turbulent flow, a new boundary outlet condition for improved mass conservation with faster and more robust convergence, and the introduction of a drag model for non-spherical particles. The new multiphysics interface technology from COMSOL has been applied to electromagnetic physics affected by heat transfer. This means that you can choose and have direct control over applications like induction heating, microwave heating, and laser heating. A nonlinear magnetic material library has also been added to the AC/DC module with over 150 materials. This allows you to model a number of common magnetic materials and utilize their BH curves to describe their nonlinear behavior. Other major improvements to the electrical products are port conditions for RF and microwave sources inside of the modeling domain, Gaussian beam as a background field in the wave optics module, heterojunctions and impact ionization in the semiconductor module, and thermal diffusion of electrons in the plasma module. The heat transfer module has been given a number of improvements, including the introduction of the thermoelectric effect multiphysics interface. This allows you to model Peltier cooling and the Seebeck effect. Another addition is the ability to model necrosis through built-in integration functions within the bioheat transfer interface. COMSOL is also introducing an approximative, but much faster, method for modeling radiation in participating media. And we continue to benchmark COMSOL against standards. In this instance, against the 10 test cases from the ISO standard related to thermal performance of windows. A number of new features have been introduced in the structural mechanics module. This includes a new method to promote faster convergence and more robust modeling of contact through the penalty contact method. New options that make it easier to specify gravity, centrifugal, Coriolis and Euler forces. A new suite of solid shell and solid beam connections that expedite simulating models that mix these geometry types. And a reformulation of the beam element to now include the Timoshenko theory. Other products within the mechanical series of COMSOL have also received improvements. A new interface for simulating aeroacoustics, known as the linearized Euler equations, has been introduced to the acoustics module. This first solves for the fluid flow and then acoustic perturbations of that flow. 3 new joint types have been added to the multi-body dynamics module: fixed joints, distant joints, and universal joints. And several new methods have been added to the fatigue module that enable fatigue evaluation in non-linear materials, including thermal fatigue. The chemical reaction engineering module includes the ability to perform multi-component flash calculations based on functions from external thermodynamic packages. It also includes some additional global quantities for calculating cup mixing temperatures, average concentrations, mass fractions and the like at outlets. LiveLink for SOLIDWORKS now allows you to transfer user-defined selections from SOLIDWORKS into COMSOL selections. This is great for utilizing SOLIDWORKS functionality when, for example, you want to work on the component of an assembly as a selection within COMSOL. Further, LiveLink for Inventor now supports the ability to transfer material selections between Inventor and COMSOL. And the ECAD import module now supports the import of the ODB++ file format. The particle tracing module introduces a new approach to modeling particle field and fluid particle interactions. The solver iterates between the particle trajectories and the field to self-consistently include the bidirectional coupling. This makes it easier to quantify applications like the amount charged particle beams spread due to self-potential. Moreover, 2 new solvers have been introduced in the optimization module. These are based on the globally convergent method of moving asymptotes for constrained problems and the derivative-free bound optimization by quadratic optimization method. I'm sure you'll agree that a lot has happened with COMSOL Multiphysics in version 4.4. To find out more about these, as well as many of the other new features introduced in COMSOL Multiphysics, visit comsol.com/4.4.